Hi everyone, and welcome on behalf of Trelleborg Sealing Solutions to today's webinar. My name is Elizabeth, and in a moment our experts will be presenting our latest innovation in radial shaft seals, the Stefa Mini Radial Shaft Seal family. This webinar is presented to you by David Cayley, who is the Global Segment Manager for Industrial Automation, and Jeff Bale, Engineering Manager for Technology and Innovation. During the Q&A portion at the end of this webinar, we will also be joined by Inderjeet Singh, who's the Global Product Line Director for Rotary Seals. Thanks, you guys, for joining us today and for being our speakers.
You're welcome, Ellie. Thank you.
Thanks, Elizabeth.
So before we actually start, I'd like to just point out a few things so you in the audience know how to participate in today's event. There is a question pane at the top right corner of your control panel where you can ask questions at any time during the webinar, which we highly welcome. I will collect the questions and then we'll go through them and our experts will answer them at the end during the Q&A. And also this session is being recorded, so at the end we'll be providing a link to the recording once it's ready. So without further ado, I'm handing over to you guys, and yeah, have fun at the presentation.
Thanks, Elizabeth. Hi, everybody. My name's David, as Elizabeth introduced. I am the segment manager for industrial automation here at Trelleborg Sealing Solutions. And I've got a pretty strong background in industrial automation, probably a little over 20 years. I'm primarily responsible for our customers and application support and industry support for this segment. And with me, I'll let you introduce yourself, Jeff.
Good morning, Jeff Bale. I am engineering manager in our technology and innovations group. I sit in Fort Wayne, Indiana. My group of engineers has been designing rotary seals for 20 plus years. Just as a side set of what we do a lot of other things, and it's a pleasure to be with you here this morning.
Thanks, Jeff. All right, let's go straight into this. There's a big number at the top of your screen there. That number is 4,281,585. That is the installed and running robots in the world today. And there are estimated to be roughly 500,000 new robots per year being installed. That's a lot of robots. It's a lot of robots. There's a lot of industrial automation being installed. A lot of it is run by robots. And the main reason for that is to augment labor. We all know that labor shortages exist across the globe, to help increase productivity, improve quality, and to reduce injuries. So this is kind of the beginning point. If we think about robots and the design of robots, there's really two sides to it. There's a software side and a hardware side. We're a seal company, so we're more on the hardware side, right? And so we're looking, when we design seals, we're looking at what do the robot design engineers have in mind. They want higher performing robots. They need to be smaller, lighter. They need to accelerate and decelerate faster. They want them to last longer. They want more uptime, and they want fewer maintenance cycles for their robots. And they want their robots to be more energy efficient, through lower greenhouse gas and lower operating costs. And so when our design engineers, like Jeff, who's on the call, took on the task of creating some new seals for the robot space specifically, they took all of those concerns into mind, and they did the same thing for the seals. So for the seals, they wanted higher performing, so they came up with smaller cross-section seals. These smaller cross-sections equal less metal and lower weight, and less mass equates to faster acceleration and deceleration. They wanted them to last longer, so they went through some rigorous design and material selection to ensure that these seals will last longer in the application, and they wanted them to be more energy efficient, and this is achieved through lower friction and lighter weight as well. With that said, I would like to introduce the Stefa Mini Radial Shaft Seal family. That's what we're here to talk about. And within this family, there are three types of seals. There's the Stefa Mini RSS, which is just short for Radial Shaft Seal. The Stefa Mini Cassette Seal. and the Stefa Nano RSS. And from this point forward, Jeff is going to take us through some of the product details for each one of these. Jeff?
All right, so let's get started on the technical stuff. So the base of our project was um, to build a small compact design. Our target was 5 millimeters by 5 millimeters in cross section. Some of the goals that we were given, we had to be compatible with the oils and the greases used in the applications that we see around the world when we talk to the customers. What we heard from our customer base is when they've gone to these small cross-section seals, one of the challenges that they have was seal retention in the groove. So we developed a simple modification to the hardware that creates an interlock with the seal. We put a small groove in the bore that interlocks with one of the ribs on the seal, and that holds the seal in very well. We went for lower torque, and that's relative because as the cross section gets smaller and you're trying to maintain your ability to follow the shaft and generate the interferences that you need from a seal design, torque does tend to go up, but it's all relative compared to some of the other applications and solutions we've seen in the market for these where they were maybe using polyurethane or heavier loaded seals. This is definitely a lower torque alternative. The seal had to be designed to handle oscillatory, short rotations, short back and forth, from 20 degrees to 360 degrees. In that application, we do not see good lubrication underneath the seal compared to a lot of rotary seals. So that was one of the challenges. And that all just really describes the applications we're targeting: robotic joints, servo motors, speed reducers. Next slide, David. So for the mini rotary shaft seal, what we knew is that we didn't have the lubrication that we're used to in constant rotary applications. And when I say constant rotary, something that turns 1,000 times in one direction, and then maybe it turns the other direction, but in general, it's going mostly one direction, or there's a length of time. Because of the fluids that we were seeing in the application, the medias, we decided to focus on FKM materials because it allowed us to be resilient to those fluids and provide the really long life that we were looking for. The variants here are a double lip, what we call a TRE, which has a dust lip to keep contamination out. And then we can also remove that lip and it becomes what we call a TRA, just a single lip, keeping the lubrication in. As I mentioned already, we've developed a special groove to retain the seal because retention was really a challenge. On a 5x5 cross section at a 20-25 millimeter bore, it's not really a bit much of a challenge. But when you take that bore dimension up to 100, 110, that's a much different situation, a very narrow seal to retain into the bore. So we had to come up with an improvement. Our housing surface finishes are our standard static bore recommendations of up to 3.2 micrometers RA. The shaft, we're running on the shaft here, so it's a 0.2 to 0.5 micrometers. We do recommend that we lubricate the idea of the seal before starting the test, or not test, but the application before installing. And then you have to be careful. This is a very small, fragile cross section. You have to be careful with as you're pressing it in. It takes a little bit of force, but it has to be a very consistent force. This is not a seal that you're going to use a hammer to push in. You're going to want to have a 3D printed tool that presses the seal into place. Next slide. So with the 5x5 cross section, what we've delivered is it's just really a smaller cross section that allows you to remove some of the mass around the seal in your robotic hardware. In that part of the hardware that's moving, we're now able to help you reduce that size. If we're talking about a 100 millimeter seal, that would normally be at least a 12 by 12 cross section. Well, we've shrank that down to 5 by 5. So the whole hardware gets a little bit smaller. That smaller mass, weight savings, all helps with your energy efficiency. With the selection of the FKM, we've got you longevity. Your lifetime on the seal goes quite long. So the cost to the customer is overall reduced. Even though the seal cost may be a little bit higher, the cost to the customer is reduced. And with that, we're able to increase your efficiency and your performance on your robotics applications. Next slide. Now I'm going to talk about the cassette seal. Now this is not a normal cassette seal in that it's not unitized. This is a wear sleeve and a shield built into the seal design, and really an important part of the seal design. With this, we ended up going a little bit wider. We're at 6.5 millimeters axially, still 5 millimeters radially. We recommend this for a diameter range of 25 to 100 millimeters. Now we have just done 110 millimeters on this design. This seal design is also compatible with oil and grease applications. We also recommend that special groove in the bore for seal retention. With this shield, we believe with the right hardware configuration, we can easily pass an IP65 test. Of course, you'll have to test that to verify with your hardware configuration. It's designed for the robotics joints, oscillatory, forward reverses, the applications and servo motor speed reducers, input, output sides of the gearboxes. Next slide. So how this seal, once again, we've focused on the lubrication of the seal, minimizing its wear. We can now take on power washing. We are still, for the elastomer, we are recommending the FKM just because it lasts so much longer. We don't have to worry about environmental issues, aging issues of the FKM like we would an MBR or something like that. This seal design does have two lips. Now on this seal, one of the real advantages and real cost savings for you is that the shaft is also a static location to the seal. So instead of having to have that 0.2 to 0.5 RA shaft surface finish and having it hardened, we're providing the wear surface. So we're perfectly happy with a 1.6 to 3.2 surface finish on both the bore and the shaft. So that's a real cost savings for you. When you go to rebuild this, our seal hasn't been wearing against your shaft, hasn't damaged your shaft. You actually pull the wear sleeve off and you replace it, and you're back to a brand new seal or seal running surface. No cost for rebuild relative. This can be assembled separately, but it has to be work together. The last product in the family is the mini. Oh no, this is still the mini cassette seal. Sorry.
Yeah, that's right.
I jumped ahead. So once again, we're seeing the weight savings, the space constraints, the total cost of ownership for the customer has really dropped off with the cassette seal, with the added performance of being able to power wash it much more efficiently. So in your applications for robotics joints, speed reducers, you can see a real efficiency improvement. Next slide. Now going on to the Nano. This is a 3x3 cross section. This is getting really small. Now we don't recommend this for a very large range. We're taking this up to 50 millimeters. Beyond that, we don't feel confident in the design. The compatibility is with grease only. The gear lubes, the lower viscosity fluids, we found that it just wasn't capable of being reliable in sealing those. Now this does require a split groove. That means you're going to have your normal counter bore, but you're going to have to bring a plate in to close the groove and capture the seal. We don't have that metal component in there that presses into the bore and holds the seal from spinning. So you're going to bring in a plate to capture that. This too is designed to handle the oscillatory applications of the robot. The high acceleration, deaccelerations is what it's focused on. Servo motor speed reducers, the input and the output side of the gearboxes is what it's capable of. Next slide. Once again, we recommend lubricating the ID of the seal to make sure that it has a little bit of lubrication to get started with. On this application as well, we are recommending an FKM. This is a symmetric seal design, so you don't have to worry about seal orientation when you install it. It can go either way. This is a split groove, but the housing can be 1.6 to 3.2 RA. The shaft, once again, is back down to that 0.2 to 0.5 RA micrometers with lubrication on the shaft to get us started. Next slide. This is really compact, really giving you the optimal space savings, really helping you out. It is a very low torque seal, so really the maximum energy efficiency. The cost of ownership here is going to be optimized, and we're able to help you increase your efficiency on those joints in these locations by keeping your mass down. Next slide.
Thanks, Jeff, on giving us the product details. Now you're going to tell us about the product testing, but I wanted to say that 3 by 3 millimeters, I mean, that's small. That's a really small seal. It kind of amazes me. So I'm sorry, I'm gushing a little bit there, but tell us a little bit of how we tested to verify these seals, please.
All right. So after talking to several different customers, we built a test plan. So this is not us just pulling a test plan out of the air. We looked at the detailed specifications of different applications, gearboxes. We talked to customers about what that looks like, how they test the products. What we really determine is one of the most challenging aspects of the application is that it's oscillatory. Very short period of time, it rotates one direction. It may stop and sit there for a moment, and then it reverses. In a constant rotary application like we see in almost every other application, is that the shaft spins for a bit of time, and underneath the seal, we actually ride on a fluid film. In this application, the fluid film just really never develops. So in a lot of the product that we looked at, it just did not handle that low fluid film environment, and we saw lots of wear. To really show that off, we made sure that in our test we had a dwell between each rotation. We would hold for a half a second just to make sure that the seal wasn't maintaining any lubrication. We've done this. We did a lot of testing, and I want to show you details about that. But we've also had customers validate the designs as well. So after talking to our customers, knowing how we like to test, we developed this test plan. We would start out by doing a pressure check, a torque validation. We only did that at the beginning of the test. Then we would go into an 8-hour cycle where we were doing a 360-degree oscillation. So we would go counterclockwise, clockwise at a max RPM of 150 RPM, accelerating at 4 radians per second squared. Between each directional changes, we would have that half-second dwell. And we would do that for 8 hours. And then for 2 hours, we would ramp it up and we would go to 1500 RPM at 40 radians per second squared. Still not generating enough rotations to really generate a fluid film, but really in this case, this was what we saw was the max end of the max speeds that we saw in the robotic market. And I'm sure that's changing, but that's where we started our development work. So really for 2 hours each out of every 12 hours, we would really accelerate the testing. Then we would shut it down, and we would watch the temperature of our test chamber come back down to room temperature. Now sometimes that could happen as quickly as a half an hour. Sometimes it would take up to 2 hours. When we reached room temperature, we would repressurize our test chamber, and we would hold it for 60 seconds to make sure that we weren't having any leaks within our system. So those leaks were not only just air tests, but we would also push out grease if we were leaking. But we also looked for grease or oil coming out of the system. So those were the two methodologies of leakage, was actually this air check and also a watching for lubrication loss. We were able to do that testing in both Turin, our facility in TSS Turin, and our facility in Fort Wayne. So when we did the 5x5, the mini radial shaft seal, we started running the oil test, and we ran 6 data points to 1,000 hours. On our final iteration of the seal design, we passed all 6 of those. There was no leakage. The wear bands were really narrow, still, just barely broke in at 0.2 to 0.25 millimeters of wear bands. So we extended that testing. We went to 5,000 hour testing in the oils. When we ran those tests, we ran 5 data points and 0 failed. That means no air leakage, no lubrication coming outboard, and we also still think of our wear as part of the failure modes, and we were seeing wear bands in the 0.3 range. Still a very brand new seal with a lot of life left in it. We also ran the same test in grease, 1,000 hours and then 5,000 hour testing. So overall, we had 13 seals on the 5x5 cross section run 1,000 hour testing with no leakage. We had 7 seals that we ran to 5,000 hours, and 5,000 hours was a really long test for us, but that's what we saw was happening in the market, what our customers were asking for. So that's what we used as our verification testing. On the mini cassette seal, we ran relatively the same testing, a few less grease tests. What we actually found is that if we can seal the gear lubes, we can seal the grease. So we started with 1,000 hours. We ran 6 data points on that. Everything looked absolutely perfect. Now, we do have a little bit different wear pattern on the shaft. On the 5x5, the radial shaft seal, we've got the surface finish is less than 0.5 RA, where here we're doing this on an as stamped metal, which means that metal is probably running closer to 0.8. And so we see a little bit more wear, but nothing that caused any substantial problems in our test. We still didn't see a lot of a wide wear band. Now on our oil test, we did see a little bit of wear debris, and that was actually coming from the outboard side, not from the seal lip itself, but from the wear pad and the exclusion lip. Those seals at 5,000 hours, the grease had started to become less effective, our pre-lube, and we saw just a little bit of wear in that area. But outside of that, the seals looked really good. The sprung lip was in great shape at that time. The grease applications ran 5,000 hours, 6 seals, no issues at all. So we ran 6 seals to 1,000 hours, and we ran 9 seals to 5,000 hours in this configuration with really good results. Now on to the Nano. Um, what we actually found on this one is that with this cross section, the loading that we're able to get into the shaft, we're not able to seal the gear loops. So it is not recommended for oil applications, but it did work extremely well on the greases. Um, we ran 6 data points to 1,000 hours and had great results. And we also had three data points of 5,000 hours with no leakage, minimal wear on these seals, with really good results. Next slide.
Thanks, Jeff. The manufacturing of these seals happens at our Turin, Italy facility. This is a really high-tech manufacturing facility located in the north of Italy. I've been there. It's a really beautiful facility. It's very high-tech. Like I said, there's 20 plus molding presses, 3,700 square meters, over 100 employees, in excess of 4 million parts per year. It's ISO certified, IATF certified, EN certified. They do both compression and injection molding and a tremendous amount of testing, which I'll talk about in a second here. The facility does product engineering. They can do FEA and other simulations. They do process engineering, both in-house tooling design and manufacturing. Of course, the state-of-the-art manufacturing. It's all high-tech, fully automated equipment, and a very large test and validation space.
David, let me
Jeff,
add a comment
yeah,
here.
please go ahead. I always miss something here.
So in this product family, my team in Fort Wayne actually led the design work, but we didn't do it on our own. We actually worked with the engineers in Turin as well as their process engineers, because as you're handling these extremely small cross sections, it took a lot of effort and work to figure out how do you handle that very thin metal, because trying to get all of the seal components, the rubber OD, the metal case, the spring, and get all that into that 5x5 cross section, we really had to optimize how we packaged that. And things were small. The metal is thinner than what we would normally do for the diameters that we worked with. And what that really led us to was we had to handle those in a special way. You know, in a lot of our applications, we will tumble and coat the metals or deburr them, and you just can't do that the same way with these more fragile components. So we really had to do a lot of work from a process engineering standpoint on how we handled these components, how we supported the metal in the mold, how did we demold it, how did we trim it. All those things had to be kind of reinvented a little bit for this extremely small cross section. Back
What
to
you're
you, Dave.
seeing here is just the test area, and it's actually not all of the test area, but it's a good percentage of it at the Turin facility. This demonstrates that we do quite a bit of seal design and validation and testing at the facility for both standard products and custom products for our customers. And speaking of products like that, here's a couple examples of seals for robots that have been done in Turin. They've been around for quite a few years. And Jeff, I think I'll let you talk to this a little bit more.
Right. So the Stefa mini family, it's really about that is an offering that we have, a capability. But when you have a specialized application, what TSS is really good at is helping you optimize the solution to your application. So when you look at these applications, if you've got a painting application like the one on the left, and this is really where we started our cassette seal design. This is the big brother to it, truly big. This is probably a 12 by 12 cross section, maybe even 15 by 15. That we actually started with, and we shrank that down to the 5x5. When you need a really clean application, the one in the middle is what helps with, but also the food packing on the right hand side. These are all historical designs, but these are design iterations that we can help provide for your application. So what our goal is we have the offering of our family of products, but we can add value in other ways as well, and we're very willing to do that.
Thanks, Jeff. So in summary, the Stefa Mini Radial Shaft Seal family enables smaller, lighter, and faster robots. They provide excellent performance at high acceleration and deceleration speeds, and they help to save energy in robot applications compared to traditional robot seal solutions. There was a lot of information. I'm sure everybody has a few questions. And Jeff, if it's okay with you, maybe we'll move on to the well, first of all, sorry, I was going to have us move on to the Q&A section, but I wanted to point out we have a virtual showroom on our website, and that virtual showroom and there's other areas on the website as well that show the different seals in more detail and animated here, as you can see. This is a nice way to remind yourself, exactly what it was that Jeff was explaining to us today. So I invite you to go to trelleborg.com and check out the showroom there. Now we can go on to the questions. Unless, Jeff, you have something else you wanted to add.
I have nothing, David.
All right, thanks.
Hi again. Thanks for the presentation. And I agree, David. Let's move on to the questions that were asked. Quick reminder to the audience: you can also still submit questions. We'll collect them as we go along. So let's get right into it. Question number 1: are there stock sizes for these seals? And if not, what's the lead time?
So the stock in this particular case, as you must have seen during the presentation, actually we have some sizes available if you want to test and evaluate some of the parts. But in general, the requirement from customer to customer for various robotics application varies a lot in terms of size and the different media and different application conditions, temperature, etc., etc. So we are currently offering these seals based on the specific project request. So as soon as if you have any, application where you think these seals will be a good fit, please do reach out to us. We will provide you a solution with the proposal and also with some test data if, wherever possible. And the lead time for that is about 8 to 10 weeks in general, depending on the size and the quantity. But in general, for the new size, it's 8 to 10 weeks is the lead time.
Thank you, Inderjeet. Next question: what type of grease do you recommend?
I will let Jeff to answer this question. Jeff.
Okay. Recommending grease, a specific grade, is really not my forte. What we recommend is that whenever you do select a grease, let's make sure that we do an evaluation of its compatibility with our elastomers. What we know and what we've seen is that some of the fluids that we do see can be quite aggressive. Now, the FKM that we're leading with is quite robust to most everything that's going to be in the field in these applications. But let's just verify. We have great lab capabilities to support that. I highly recommend that we do an evaluation to make sure that we're going the right direction.
Thank you, Jeff.
Thanks, Jeff. Next question would be: in what kind of materials are these products available?
So I can answer this question maybe. So as Jeff very briefly mentioned, so most of these seals are currently available in FKM materials. Because of the application requirement, the speed, the media, the temperature, and the acceleration, which really these seal faces. So FKM is the best fit material, but that doesn't mean that we can have only FKM. So if you have a specific within the FKM range, we can have a different range of temperature range, different kind of formulation in FKMs available. So other than FKM, we have huge portfolio of the material where we can choose from to offer you best solution in terms of to make sure that the performance is seal is optimum, and then you get the best product in the end of the day, which meets or exceeds your expectation in terms of application performance.
Cool, thank you, Inderjeet. What is the temperature range for those seals? Is the next question that was asked.
Oh, the temperature range again, it depends what your application need, So our seals can withstand a wide range of temperatures. Those has been tested in the wide range of application temperature range. But we have material available, and this is a combination of material and the designs where we can offer you something like starting from minus 40 degrees centigrade to up to the maybe 170, 160. But again, those are very specific applications where we need to make, we can offer you a solution. But in general, if you talk, I mean, these applications didn't go beyond minus 15 to 120 or 130 degree. But again, I'm repeating, if you have any specific temperature range in mind, we can offer you even broader range depending on your application need.
Yeah, makes sense. Thank you, Inderjeet. Next question is, can you elaborate on the 5,000 hour test? To what lifetime would you say that it is equivalent?
I think Jeff is better placed to answer this question. So Jeff.
Okay, so the 5,000-hour test was selected based on what we saw customer validation processes being. So we're really just duplicating that. As far as to say a lifetime, it really depends on the application. How fast are you running it? What temperatures? What is your contamination level? Because that's going to be a key driver on how long the seals last, how long your hardware lasts underneath the seals. So I can't say it's definitely not that the 5,000 hours is a maximum. It is where we tested to verify our designs. They can go much longer. As I mentioned, the seals were in great shape at that point, but that was also lab conditions. Could they go in the field? Do we expect longer times? Absolutely, but it's really going to depend on how your application, what your conditions are.
And I would like to add what Jeff said is that, so Jeff just summed up nicely here. So on top of that, these 5,000 hours was based on our some key customers who were looking after, those kind of solution for quite some time. And then we had a very close collaboration and, partnership with them. And then we come up with this 5,000 hours of testing duration for the validation of these seals.
Yeah, thanks both. The next question is actually a little bit long. So they say, thank you for the excellent presentation and highlighting the special operating conditions in robotic applications. I'm involved in the evaluation of robots for hygienic applications in food and pharma. The mini cassette solution seems to be the right application for such applications. My question is, have you considered higher IP classes than 65?
It's a very good question, Ali. I think so. And within the robotic application, the food contact application or the robots which get in touch directly or indirectly with the food is one of the very focus area for us and of course for our customer. In this particular case, we say that, okay, I mean, we have a specific type of IP classes which covers already, which I think Jeff and David briefly explained. But if you want to go, I mean, if you want further, different IP, grades where you want these seals to perform, we can always fine tune or modify your these designs and the materials portfolio, and we can pick from the portfolio of the material to give you a solution which can easily work in this kind of conditions. So because, and on top of that, as we have a huge portfolio of the food approved materials, which we are using it globally for various food contact or similar applications. Plus, one of the uniqueness, like in the presentation you heard, uh, for these kind of applications, of course, you need materials which are really approved for those kind of application usage, and you need the capability of the special hygienic designs, which we can do. And you, I think David and Jeff showed in one of the presentation, we have those capability to make sure we offer you hygienic design plus approved material, and on top of that we can customize based on your specific application need. We have been working in those applications for many years, and we have a lot of success stories and so many options to offer you in terms of custom solution for food contact applications or similar pharma application also wherever it's needed.
Cool. Thank you, Inderjeet. I believe the next question is for Jeff. Correct me if I'm wrong. It goes: is the runout/coaxiality more critical on Stefa than standard lip seals because of the small cross section?
Absolutely. Yes, our ability to follow the shaft is affected by the small cross section. Now, in these applications, and when we compared them to other applications where your RPMs tend to be much higher. We're used to our revolutions per minute in the 3,000, 8,000. At 150 to 1,500, the elastomer is able to follow the shaft much better, which has allowed us to shrink it down. We're also very often placed very close to the bearing, so that helps as well. But yes, coaxial run out, this small cross section is not able to handle that as easy as a larger, more flexible seal cross section.
Okay, moving on, there's a bunch of more questions on material. First question being, how do you manage the PFAS issue with the FKM material?
So on the PFAS issue, this is one of the key topic at the moment for us as a sealing solution providing company. To be honest, not just for us, for many similar companies in the market. We have a core team in Trelleborg Sealing Solution who are working to specifically focused to handle PFAS related solutions. We have really come a long way now with an option of alternate PFAS alternatives. So for example, one of the material which you saw in this the test data where we showed it to you, FKM used actually is a PFAS free FKM we are now currently offering. And on top of that, we have other non-FKM solutions also which we can use. But again, it depends on your application needs and the media and so on and on. So to answer your questions, we have options to offer you PFAS free or alternative to PFAS products and the materials. And if you have any specific thing again in the mind which you think a particular application will need a PFAS-free solution, we will be more than happy to discuss and provide you appropriate solution for that application.
Yeah, thanks, Inderjeet. I have another question here saying, what kind of materials are these products available?
So I think I kind of answered this question in previous couple of those. So as I said, we have a huge portfolio of the materials. I mean, so it all depends on your application need. So in general, by default, recommendation comes to the FKM because of application need in general. But again, if you have specifically low temperature FKM required, we can offer you that. If you have specific media compatibility, we can offer you need food or pharma approved, for example, materials you need, we can offer you those materials in FKM and HNBR, NBR. Okay, all of those may not exactly work in those applications, but we can definitely offer you the best options so that which can fulfill your application requirements. But again, it depends what application need, and we can always definitely offer you more than one option in most of the scenarios.
Yeah, thank you, Inderjeet. That makes sense. I think the questions we have left are all fairly specific use cases. So I suggest we reach out to these people specifically in detail as a follow-up. Is there anything you would like to add? Otherwise, it looks like we have reached the end of the webinar.
Don't have anything.
Nothing from my side. So, I mean, I think it's great to see so many questions. So, still so many specific questions. It's great to hear that. We would like to get in touch with all of you, those who haven't got the answer. I think that's it for me.
Great. Thank you, David, Jeff, and Indrajit for the presentation and for the further insights. Also, big thank you to everyone in the audience for listening and for asking so many insightful questions. As mentioned, we'll reach out to you in detail if your question wasn't answered today, and you'll receive a link to the recording of today's session once it's available in the next few days. So yeah, thank you for joining us today and enjoy the rest of your day. Bye.
Thank you all.
Thank you. Bye bye.